Hi there. On this video, I will cover multi-level feedback queuing. Alright, so this requires knowledge on the basic CPU scheduling like first come first serve, round robin, short job first, and priority scheduling. Okay, so let's start. Now let us define a multi-level feedback queuing. Okay, so in a multi-level feedback queuing, this basically combines several algorithms. Okay, so the first 6 algorithms, which are first come first serve, short job first preemptive and non-preemptive, priority preemptive and non-preemptive, and round robin, are being used. Okay, so on a multi-level feedback queuing. Right, so a process can move between various queues, and aging can be implemented that way. Alright, so on a multi-level feedback queuing, okay, so the multi-level feedback queue scheduler defined by the following parameters. So you've got the number of queues, the scheduling algorithms for each of the queue, the method used to determine when to upgrade a process, when to demote a process, and the method used to determine which queue a process will enter when that process needs service. Alright, now referring to this diagram here, okay, so we have here 3 different queues. Alright, so you've got Q1, Q2, and Q3. Right, so these queues are operating based on the priority. So processes on Q1 will be the highest priority, process on Q2 is next, and processes on Q3 will be the lowest priority. Alright, able to finish on Q1, it will move on Q2, and from Q2 it will move on Q3. So in a general case, if a process does not complete in a time quantum, then it is shifted to a lower priority queue. Alright, so in the last queue, processes are scheduled in the first come, first serve manner, considering again the priority here. Alright, so next, a process in a lower priority queue can only be executed only when the higher priority queues are empty. So that means we cannot start Q2 unless there are processes, or there is still at least one process on Q1 running. And we cannot execute Q3, alright, which runs in first come first serve, if there are processes currently being executed on Q2. Alright, So a process running in a lower priority queue is interrupted by a process arriving in the higher priority queue. All right. So remember that a process running in the lower priority queue is interrupted by a process arriving in the higher priority queue. Okay. So well, the above implementation may differ. For example, the last queue can also follow a round-robin scheduling. So there is a possibility that the third queue also uses a round-robin scheduling. So this queue can use any of the 6 basic algorithms that we have studied on CPU scheduling. All right? Next, so problems in the above implementation. So a process in the lower priority queue can suffer from starvation due to some short processes taking all in the CPU. Alright, so there are processes that taking time to the CPU, and the rest of the processes that is in the lower priority queue, well, it has to wait for a very long time, and we call it starvation. Alright, so what is our solution to this? So a simple solution can be to boost the priority of all the processes after a regular intervals and place them all in the highest priority queue. Right? So that's the solution. Okay? So what is the need of such complex scheduling? First, it is more flexible than the multi-level queuing scheduling. All right? So to optimize the turnaround time, algorithms like short job first is needed. Okay, so that is requiring the running time of a process to be scheduled. But the running time of the process is not known in advance, right? So the multi-level feedback queuing runs a process for a time quantum, and then it can change its priority if it is a long process. So thus it learns from past behavior of the process and then predicts its future behavior. So this way, it tries to run shorter process first, thus optimizing the turnaround time. Alright? So the multi-level feedback queuing also reduces the response time. Now, so I have here an example of the multi-level feedback queuing without the predefined condition. All right. So let's run this 4 processes here. Okay. Given these 4 processes, the arrival time, the burst time, and the priority. All right. So the first priority here is P4. Second is 2. Okay. P3. Third is P2, and the fourth priority here is P1. Alright, so we are going to consider on Q1 we will be using round robin quantum of 1. Alright, on Q2 we will be using round robin quantum of 2, and on Q3 we will be using first come first serve. Alright, so at time 0 I have here an illustration. Okay, so I want you to observe the time there for every tick of a time. Alright, so an event is happening here, right? So at time 0, from the given, it's process 1 who is in the ready queue. Only process 1 is in the ready queue at time 0, all right? And this process requires 7 milliseconds of burst time. Okay, so at time 0, process 1 is in the ready queue of queue number 1, and it will be implemented using round robin quantum of 1. All right, so let's start. So at time 0, P1 is there. Okay, so this P1 will be moved to Q1 on the CPU for execution, and it will be given a quantum of 1. Right, so we have here a quantum. Okay, initially it's set to 1 because the quantum here is 1, and it expires when it gets 0. All right, so when it gets 0, okay, so that means process 1 has finished the execution after 1 millisecond. So in here, at time 1, currently P1 is executed. So executing 1 millisecond, so therefore we have executed 1 millisecond of the burst time for P1. And therefore, at 1 millisecond, it will be preempted. Alright? And therefore, since P1 was not able to finish the execution, okay, so therefore it will fall in line on Q2. Alright? So P1 would be the first process to be in the ready queue. Okay, so for a round robin quantum of 2. Alright? So after 1 millisecond, we only have one process that was executed under round robin quantum of 1 in Q1. Alright? So what will happen is this P1 here will continue its operation or execution, okay, until the time quantum here of 2 milliseconds expires. Alright? So each processes on the Q2 will be given 2 milliseconds quantum. Alright? So at time 1, only P1, the only process in the queue, and is now currently being executed until this quantum time 2 here gets 0 and expired. Alright? Now, during the execution of P1, okay, on Q2, so at time 2, process 2 already came in the ready queue, and process 2 needs 4 milliseconds here. Alright? So that is at time 2, and we still have 1 millisecond remaining for the quantum for P1. Alright? Next, at time 3, okay, so P1 was able to execute 2 milliseconds of the burst time, and therefore at time 3 it will be terminated and preempted, alright, and move to the first come first serve ready queue. Alright, so that means after 3 milliseconds, so process 1 has moved on the ready queue for the Q3, and it has a remaining of 4 milliseconds quantum. 4 milliseconds burst time. Alright? Next. So take note that during the execution of P1 here, okay, so P2 was already on the ready queue. So therefore, P2 has make it on the Q2, right? So P2, which is the third priority, will be executed for 2 milliseconds quantum, right? So at time 3, at time 4, until this quantum gets 0 at time 5, right? So therefore, P2 was executed for 2 milliseconds. Alright? Now, after 5 milliseconds, we still have 2 processes on the queue. So that means P3 and P4 has made it on the second algorithm, or on Q2. Alright? Now, who will be executed first? P4 here is the highest priority. So we give the execution, okay, so to P4. So P4 will be given also 2 milliseconds quantum. Alright? Next, at time 5, so P2 has finished the execution, right? And therefore, we'll join P1 on the ready queue for the first come first serve. Alright? Next, P4 will be given 2 milliseconds here, quantum. Okay? So, and therefore, that will end up at 7 milliseconds. Alright? So, after 7 milliseconds, P2 has remaining 2 milliseconds burst time. And therefore, this P4 here will move on the ready queue for the first come first serve. And eventually, right, so this will rearrange based on the priority. So take note that on Q3, we have not yet started here because we are not yet done with Q2. Alright? So we still have a process, so we still have P3 as a process on Q2. Alright? And P3 needs 1 millisecond there. So it is now currently being executed and was able to deduct 1 millisecond from each burst time. Okay? So that means after 1 millisecond, P3 was the only process who has completed execution. So, and it has completed on a Q2. So that means after P3 has been terminated, okay, so we are now ready to start Q3. And on Q3, there were already 3 processes on the queue. Alright, so that was P1, P2, and P4. Okay, so what will happen here is, so we need to implement a priority first come, first serve. Alright, because we do have the priority there. Alright, so P4 has a remaining 2. Okay, so that means after 10 milliseconds, so P4 has already completed its execution. Alright, so we still have P2 on the queue. So after 12 milliseconds, so P2 has completed the execution. And the last one would be P1 with 4. Alright, so that will end up the execution at 16. Alright, so this is our Gantt chart. So that means P4, P2, and P1 here, the remaining burst time was executed on algorithm number 3 or on Q3. So this is Q1, Q2, and Q3. Alright, so it's time to get now the table. Alright, let's derive the table from the Gantt chart. Let's start with the turnaround time here. Alright, so P1 has finished 16 minus the arrival time 0, so that's still 16. Alright, next, process 2 has finished the execution at 12 minus 2, that's 10. Alright, so process 3 has finished the execution at 8 minus 4, so that would be 4. And process 4 has finished the execution at 10, right? So 10 minus 5, that's still 5. Alright, so the total would be, so added 35 divided by 4, that's 8.75 milliseconds. Alright, now for the waiting time, so initially P1 never waited here, but it was preempted at 3 and resumed its operation on 12. So 12 minus 3 here, alright, so that would be 9. Okay, so for process 2, it has waited here 3, preempted at 5, resumed at 10, 10 minus 5, that's 5, plus 3 here, initial waiting time, so that would be 8, minus 2 arrival time, so that would be 6. Alright, next, for P3, it has waited 7 milliseconds here, so 7 minus 4, that's 3, and for P4, it has waited here 8 milliseconds, right? So initially it has waited here 5, preempted at 7, resumes at 8, so you've got 1 here, right, plus 1, that's 6, minus 5, that's 1. So total is 19 divided by 4, you've got 4.75 milliseconds. Alright, so that's it for the multi-level feedback queuing. Thank you for watching.